Okay, so we're on worksheet 2-2. All right, and they give us, we're going to start on question 11. If you want to cross off the first 10, you can. And then if you want on the back, you can cross off after 92. We're only going to go as far as 92. You're not going to go all the way to 114 or whatever, 115. So
92 down.
The assignment's going to be 11 through 92.
Oh, it's 93 down.
Yes, cross off 93 down, I'm sorry. Yeah, so, okay. So we look at question number 11, okay? And this may sound like I'm being sarcastic here, but it's important that you guys read the instructions, okay? Because sometimes if you don't read the instructions, it makes it hard for the questions if you don't read the instructions. So they tell us that these points are on the unit circle. If you look at 11, you're like, well, yeah, I know radical 3 over 2 and 1/2 is on my unit circle. I wrote it down, okay? Okay, good. So they want all 6 trig functions. Now, if you're going 6 of them, we've only learned 3 of them. We learned cosine, sine, and tangent. I might have briefly mentioned, I don't remember, about the 3 reciprocal functions, secant, cosecant, and cotangent. Did that sound? Okay. So if you...
Some of that sounded right.
Some of that sounded right? Okay. If you didn't put this on the back of unit circle, you might want to put it on there. We have sine, we have cosine and tangent, and then we have cotangent, secant, cosecant. That's SEC. Okay? And we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Cotangent is adjacent over opposite, secant is hypotenuse over adjacent, and cosecant is hypotenuse over opposite. They're just, oops, I don't want that. They're the reciprocal functions, okay? We are not going to write down on our unit circle all the cosecant values, all the secant values, and all the cotangent values. We're just going to look at what we have, and we're going to flip them, okay? So those are ones that you definitely, I mean, you need to know SOHCAHTOA. On the left, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, that's SOHCAHTOA. There's no cute little word for this one that I know of, okay? But it's just the reciprocal functions. And I don't want to give anybody bad ideas, but just be careful. A lot of students think, and the way you read this is cotangent. That makes sense that it's the reciprocal tangent, cotangent. This one is cosecant. Be careful. Students tend to think cosecant is a reciprocal of cosine. It's not. Secant is a reciprocal of cosine. And CSC is cosecant. Cosecant is a reciprocal of sine. Okay? So, when we look at number 11, they give us radical 3 over 2 and 1/2. Okay? So, on our unit circle, we know that at radical 3 over 2 1/2, that is, what is the angle there? 30 degrees. I heard 30 and 60, which is 30 or 60? Isn't that 30 degrees? Radical 3 over 2 1/2? Isn't it 30? Okay, I heard more than somebody else say 60. I don't remember who it was. So, here's the deal though, okay? Even though we know it's 30, we're just going to pretend that we don't know the angle. We don't know it, okay? So, we're going to say the sine of, we don't know the angle. In algebra, we put x. What do we put if we don't know an angle in trigonometry? Do we put an x? Is that what we use?
Theta.
Theta. Looks like a 0 with a line through it, kind of. And you should be able to tell me right now, and not to put anybody on the spot, but if you can't answer this, you're a little behind here. What is the sine of this angle? Uh-oh. 1/2. Why? Because the sine is the y value. Sine's a y value. Sine is 1/2. The cosine should be just as easy. Radical 3 over 2. Cosine is the x value. Just don't mix those up. And tangent of theta, well, if we look at our unit circle, and the circled numbers is radical 3 over 3. Okay, we're halfway done with this question. Then we're going to have the cotangent of theta, the secant of theta, and the cosecant of theta. And I get it. Like I said, there's a lot of writing in these, but I'm doing it right with you guys. So, which one do you think would be the quickest to find? The cosecant, the secant, or cotangent on this particular one? What do you guys think? Actually, I would say cosecant would be the quickest. You'll know why here real quick. I mean, if you flip 1 over 2, you have 2 over 1. If I flip tangent to get cotangent, wait a minute, that's not hard. It's just 3 over radical 3. We're not done. What'd you guys say? and radical on the bottom. Okay, we didn't have to worry about that back here. So we times the top and the bottom by the bottom, so times by radical 3, times by radical 3. 3 times radical 3 is 3 radical 3. Radical 3 times radical 3 is radical 9, which is 3. Did I get rid of the radical on the bottom? Yep. We all done? Not quite. Cross off the 3's. Okay? So radical 3. So in 2 words, the way we find cotangent, flip tangent. That's all you're doing. You're flipping tangent. How do we find secant? Flip cosine. This one's going to take a little bit longer than cosecant also, because we flip radical 3 over 2, we have 2 over radical 3, which is unacceptable. We times the top and the bottom by the bottom, times radical 3, times radical 3. 2 times radical 3 is 2 radical 3, over radical 3 times radical 3, which is radical 9, which is 3. Any question on that one? A lot of writing, but just looking at the unit circle and flipping things around is all we're basically doing. Okay, number 13. They give us the point. Negative 2/5. See all you guys were listening a minute ago. You gonna use unit circle on this one? No, you're not. Is this point on the unit circle? It's not on the unit circle? Really? How do you know it's on it? I'm not saying you're right or wrong. Is that point on the unit circle?
Well, I mean it is, but we don't.
How do you know
have
that?
a label
How do you know that?
Because all of it's on the unit circle.
Everything's on the unit circle? Every point you ever plot? How do you know this is on the unit circle? Oh, you weren't listening about 10 minutes ago. Read the instructions. Is this point on the unit circle? Why? It says it is. It says the point is on the unit circle. Now, it's not written on unit circle. It's not written on it, okay? But it's there somewhere. Be careful. Every point is not on the unit circle, okay? But this point is on the unit circle. It is on it, okay? And I tell you what, if you can answer this, phenomenal. This would be great. If not, it's really okay. If you had to guess, and I'm looking for a big range here. You don't need to have it really, really, really close. We're talking a huge range you could have here. Don't say like from 0 to 1 billion. That's too big of a range. But if I say, what angle would you say that is? Somewhere between what and what do you think? If we're at the point negative 2/5, positive radical 21 over 5. Anybody have a guess?
Between 90 degrees and 180 degrees.
Between 90 and 180? You got exactly 2 words to explain why. You're right. Tell me exactly why in 2 words.
Negative, positive. Left, up.
Left and up. That's even better. Negative positive means left. It's somewhere between 90 and 180. I have no idea what it is, but it's somewhere between 90 and 180. Good job. Okay? But even so, we should know, without our unit circle, what our sign is. It's the y value. Radical 21 over 5. The cosine value is negative 2/5, the other one. The tangent. How did we calculate the tangents? You guys remember when we filled in the unit circle? How did we figure out what the tangent, those circled numbers? You guys remember how we did that? It's on the back of your unit circle. Tangent is what? It's opposite over adjacent. It's also sine over cosine. It's also sine over cosine. Now, here's what's nice is this. I'm not going to write my sine over cosine here because if you look, what do I got? I've already got my sine over the cosine. So picture this as this over this. Just picture there's a bar right there, okay? And I showed you a little trick here. We got a fraction over a fraction, and our denominators are the same. So we could wipe those out. So far, we have what? Radical 21 over negative 2. Is that okay for an answer? Or not? We got a radical in there. Is that okay? Yeah.
It's on the top.
As long as it's not, and it doesn't have to be on the top. It just can't be on the bottom. Okay? All right. So let's put cotangent of theta, secant of theta, and cosecant of theta. Which ones do we want to find first on this one? Cosecant, secant, or cotangent? One of them is easier than the others. Which one do you think?
Secant.
Why?
Because you just flip 5 over negative 2. and
Is that
there's
okay?
There's no radical.
There's no radicals. Okay? The ones that have radicals, those are the ones that are a little more work. So to find secant, flip cosine, negative 5/2. and leave it -5/2. Don't make it -2.5 or -2.5. It's just typically in trig they use improper fractions, okay? All right, so to find cosecant, I'm gonna flip sign, doesn't matter what, I mean, you can find them in any order you want, I just like to do the easiest stuff first. So to find cosecant, we flip sign. So we have 5 over radical 21, which is unacceptable. We times the top and the bottom by radical 21. 5 times radical 21 is 5 radical 21. Radical 21 times radical 21. When you take a radical and you times by itself, you get that number without the radical. Radical 21 times radical 21 is just regular old 21. Radical 73 times radical 73 is just 73. Okay? All right, so that's the cosecant. To find the cotangent, we flip the tangent. So we have -2 over radical 21, which again is unacceptable. Can't have radicals in the bottom. We times our radical 21 on top and bottom. -2 times radical 21 is -2 radical 21 over radical 21 times radical 21 is regular old 21. Question on that one? Okay, 15. This one you can use your unit circle on because you see negative radical 2 over 2, positive radical 2 over 2. Okay? And again, like what Cassie said a few minutes ago, if I was to ask you for the angle, I would really hope you're not looking at the entire unit circle. You really shouldn't have to. Okay, if you understand it, negative means left, positive means up. You should be looking at the upper left-hand corner of it. Okay, and if you do that, it's 130. Is it 135 degrees or is it 3 pi over 4? Which is it? Which angle is it? 3 pi over 4 or 135 degrees? So I want to make sure you guys understand. Their angles can be measured in degrees or radians, okay? You might say, it's 135 degrees, I like degrees. Okay, you like degrees? I don't care. You can still use radians. It's the same, it's a different way of saying the same thing. I mean, is this class roughly an hour or roughly 60 minutes? It's the same thing, okay? 2 different ways of saying the same thing, okay? So one of you is looking at 135 degrees, somebody else is looking at 3 pi over 4. You're both right, okay? But we don't even know that. We're just saying theta. We don't know that. We're just saying it's theta. Sine of theta, cosine theta, tangent of theta. Okay? Sine is the y value, which is radical 2 over 2. Cosine is the x value, which is negative radical 2 over 2. Tangent is -1. Okay? And be careful on this one. Some students struggle with flipping -1. If you flip, you know what the reciprocal of -1 is? -1. You know what the reciprocal of 1 is? 1. There's 2 numbers out there that are their own reciprocals. 1's reciprocal is 1. -1's reciprocal is also -1. Is 0 also in that group? What's 0's reciprocal? 0 has no reciprocal. Okay? So if you flip -1, it stays -1. I want to show you guys a little shortcut here. Okay? We'll do this next one the long way. Then I'll show you a little shortcut that you don't need to know, but it saves you a little bit of time. If we flip cosine to get secant, we're going to have -2 over radical 2, unacceptable, times radical 2 on top, times radical 2 on bottom. We do that, we have -2 times radical 2 is -2 radical 2. Radical 2 times radical 2 is regular old 2. And the 2's cancel, so we have negative radical 2. I'm not going to show my work on cosecant, and the reason is, these are the same, except for this is negative, so this is going to be positive. So instead of negative radical 2, it's positive radical 2. If you want to show your work, you can, but it's not really necessary. Now, here's the little shortcut that you can do. If you noticed here, when I had radical 3 over 3, the reciprocal was just radical 3. When I had radical 2 over 2, the reciprocal is radical 2. If I gave you radical 7 over 7, you know what the reciprocal of radical 7 over 7 is? It's just radical 7. You don't have to know that, but it's nice. It's nice to know. Okay? If I gave you radical 11, the reciprocal of radical 11 is radical 11 over 11. So that's kind of nice to know. Save you a little bit of time. Okay, but again, if you don't get that, just show your work and do it the other way. 17. 2 radical 2 over 3. And what? Negative 1/3. Okay. Okay, so again, this is on, your unit circle is not going to help you on this one, okay? But it is on the unit circle. It's just not written there because they tell you it's on the unit circle, okay? And I'll show you at a later time how I can prove it's on the unit circle. It's actually not that difficult, okay? So, we have sine, cosine, tangent. Well, the sine's negative 1/3. Cosine's the x value, 2 radical 2 over 3. Okay. Now, I do want to give you a little bit of heads up on this next thing. I'm going to show my steps. Well, I want you guys to think about this without me just telling you, okay? To find the tangent, we're going to take sine over cosine. So we have this fraction over this fraction, okay? And then I have the same denominators, 3, so I can just wipe them out. I'm going to write down negative 1 over 2 radical 2. Now that's not our final answer, okay? And I want you to show your work. That's not the reason why I'm asking this though, okay? Even though we're going to still show our work, why do you think I'm going to write that down? I mean, I'm going to change it. We can't have that radical on the bottom right now, but why do you think no, forget that. I'll ask you that question here in a second. Let's times the top and the bottom by radical 2. Times radical 2. To get rid of that radical on bottom. Negative 1 times radical 2 is negative radical 2. And be careful here, some students get messed up on this. Radical 2 times radical 2 is radical 4, which is 2. We take 2 times 2, which is 4. Cotangent, secant, and cosecant. The easiest one to do is sine. Negative 1 over 3 would be negative 3 over 1. If you put negative 3 over 1, that's fine. I'm just going to put negative 3 though. Okay. I'm going to do cotangent next. What I was trying to get at, and I think I might have confused some people, is to get cotangent, I flip tangent. I'm not going to flip this right here, even though that's what the tangent is. You know what I'm going to flip? This one back here. I mean, these are all the same. These are equal to each other. Why do you think I'm going to flip this rather than that?
Because then you're gonna go through the process again.
What do you mean?
Because you're gonna go to radical on bottom.
If I flip this, what?
You have a radical on top.
And not one on bottom. So that's what I'm saying. Even though this wasn't part of we didn't want that for our final answer, I kept it because this is what I want to flip. I could flip this, but it's going to be more work, so I don't have a radical on the bottom. You got to get rid of it again, okay? So flip negative 1 over 2 radical 2. You're going to get 2 radical 2 over negative 1, which there's nothing wrong with that, but a simpler answer than 2 radical 2 divided by negative 1 would just be negative 2 radical 2. So when you divide by 1, nothing happens. When you divide by negative 1, you get the opposite. Okay, now we can't really do that with secant. We're going to have a radical on bottom either way, so 3 over 2 radical 2. We times the top and the bottom by radical 2. 3 times radical 2 is 3 radical 2. On bottom, we take radical 2 times radical 2, which is radical 4, which is 2, times 2, which is 4. Any questions on these? Okay, so these next ones, a lot less writing on these now, at this point forward. Okay, now they want the exact value. Do not use a calculator, okay, because you don't need a calculator when you get to number 19. Okay, and we've already done questions kind of like this. They ask us to find the sine of 11 pi over 2. We did a question or two like this on our last worksheet. Okay, the sine of 11 pi over 2. I would really encourage you take any improper fractions, and not theta, and make them into mixed numbers. Sine of 11 pi over 2. Now, not to embarrass anybody or put anybody on the spot here, but you should be able to answer this right now. Yes, sir.
Is that SCC or SEC?
Oh, this right here?
Yeah.
SEC, I'm sorry,
Okay.
S-E, yeah, secant. Yep, SEC. Yep. And this is CSC for cosecant. It's also my son's initials. Okay, so I would rewrite this as, instead of 11 pi over 2, as 5 1/2 pies. Okay? 5 1/2 pies. And what I'm getting at is you should be able to tell me, I mean, where is 5 1/2 pies at? What would that be? Well, 5 pies,
It's right here, right?
yes. Okay, how'd you get there? What'd you do?
You gotta go here, 1, 2.
Yeah, what he's doing, well, you don't need to draw this, but you should be able to do this, in your head. This is 1 pi, 2 pies, 3 pies, 4 pies, 5 pies. So it's 2 1/2 times around. That's 5 pies. And be careful. We still have to go another half pi. This is not half a pie, which is tough because when you look at this, if we're talking pizza, looks like there's 1 pizza there. It's really 2 pizzas, okay? All the way around is 2 pies. 1 pie looks like half of a pie, okay? So we have to go halfway more, right about here. And what is the value there? Okay, it's 270, but I want the sign at 270. I want the actual sign. The sign is the what value?
The 1.
-1. -1. You don't have to draw these little circles, but you got to be able to picture it. You're going 2 1/2 times around and then another quarter of the way around. Tangent of 6 pi. So describe 6 pi. Be able to describe that in 3 words. What is 6 pi? If the track coach says go run 6 pi, you can actually, if you say it that way, you say it in 2 words. You're doing what then? 3 laps. 3 laps around the track, okay? And where do you end up? Right where you started. And tangent there is
0 over 1.
0 over 1, which is 0. I'll accept 0 over 1, but 0 is a better answer. So just 3 times around. Cosecant of 11 pi over 2. And I don't think this is cheating. I think it's being efficient. And we've already answered this today. Okay? When I say be efficient means use all of your resources that you have. Okay? What's the cosecant of 11? If you want to draw a bunch of circles again, you shouldn't have to. What would the cosecant of 11 pi over 2 be? Why? Who said that? Why?
Because it would be the opposite.
Don't say opposite.
The reciprocal.
Good.
Of sine, and
11 pi over
that's
2?
-1.
And what do we say the reciprocal of -1 is? -1. Yep. It's not cheating. We did 2 problems ago. Same angle, it's a reciprocal, and it's not like I'm being picky here. You said opposite. Technically the opposite would be +1 then. So it's -1. We look back here at this answer, it was -1, flip -1, still -1. Okay, hopefully that's still recording. Yes, it is. Okay, number 25. Cosine of -3 pi over 2. You can use your unit circle on this, okay? You can, even though you don't see -3 pi over 2 written anywhere on your unit circle, okay? What you need to understand is 3 pi over 2 is that far. So describe -3 pi over 2. Which is farther? Same distance, opposite way, okay? So instead of going 3/4 of the way around this way, you go 3/4 of the way around that way. You went the wrong direction. And the cosine is the x value, which is 0. The secant of negative pi. Well, negative pi, again, you don't see negative pi written on your unit circle, but you see pi. Pi is here. Where's negative pi going to be? Same spot, opposite direction. You went the wrong way. Okay. All right. We don't have secant written down on our unit circle. We don't have it written down. Well, what are we going to look at to find secant on our unit circle? The what? Cosine. And what is a cosine there? Flip it. Okay, just a few more on the back and then we will do our homework quiz. Don't get thrown by 29 through 48, okay? It says find the exact value, do not use a calculator, okay? All you're doing on these is well, I'll tell you what, I'm not gonna tell you, you guys will work through it and you'll tell me. It says the sine of 45 degrees plus the cosine of 60 degrees, okay? The sine of 45 degrees plus the cosine of 60 degrees. So how the heck are we going to find that without a calculator? Well, how do we find the sine of 45 degrees without a calculator? Look at unit circle. What is the sine of 45 degrees? Radical 2 over 2? You look at the first value or the second value? Good. I mean, they're the same. That's why I'm asking. They're the same, but on that one. But make sure you're looking at the second one. Radical 2 over 2 plus the cosine of 60. What's that? 1/2? Okay. And you can leave it like that, or I think make it a teensy bit nicer. Since you have a common denominator, if I gave you something like this, a over 7 plus b over 7, what's another way I could say a over 7 plus b over 7? Careful, not ab, a plus b, because what's wrong with ab? That means times. So what's one that's saying radical 2 over 2 plus 1 over 2? Radical 2 plus 1 over 2. That's all it is. That's the exact answer. All you're doing is looking stuff up still, and then doing simple computations. 31. Sine of 90. I'm going to shut my mouth here for about 30 seconds, and I want you guys to do this one. What is the sine of 90 plus the tangent of 45? Go ahead and give this one a shot. Instead of looking up a value, you're looking up 2 or 3 values and then doing what they tell you to do with them. I think they got it? What'd you get? Should be 2. How'd you get 2? What's the sine of 90? Plus, what's the tangent of 45? Answer's 2. 1 plus 1. There's nothing special about these problems. I just want to make sure you know how to use unit circle. 33. Be careful on 33 when it says, and we just talked about this a second ago inadvertently, it says sine 45, cosine 45. They're not asking you for 2 values. They're saying take the sine of 45 degrees, and there's no symbol in between there, so it means times the cosine of 45 degrees. Sine of 45 degrees times the cosine 45 degrees. Go ahead and give this one a shot, see what you get. Make sure when you times fractions, you times the bottoms. When you add fractions, you leave the bottoms alone. That's good. I just couldn't see it. It looked like something else. You guys get a half, hopefully. Radical 2 over 2 is the sine, times radical 2 over 2 is the cosine. Radical 2 times radical 2 is radical 4, which is 2. You have to times the bottoms when you're timesing fractions. And 2/4 is 1/2. Just a couple more, and then we'll do our homework. 35. Cosecant 45. Cosecant 45 degrees times the tangent of 60. Okay, so for cosecant of 45, we look at 45 degrees. The way we find cosecant is we flip sine. Okay, so the sine at 45 degrees is radical 2 over 2. See if you guys caught that little shortcut I showed you today. What's the reciprocal of radical 2 over 2? Not 2. Radical 2. Radical 2. If I said the reciprocal of radical 11, it's radical 11 over 11. Okay? So it's just radical 2 times the tangent of 60. Is that radical 3? So the answer is radical 6. That's the exact answer. One more, 37. I'm gonna shut my mouth, have you guys try number 37. And we'll go over the answer, and then we'll do our homework. So 4 sine 90 minus 3 tangent of 180. And you guys know this, but 4 sine means 4 times the sine of 90 minus 3 times tangent of 180. Any guesses?
4.
Should be 4. 4 times the sine of 90 is 1, minus 3 times the tangent of 180 is 0. 4 times 1 is 4, 3 times 0 is 0, 4 minus 0 is 4. Okay? This ain't that bad today, was it? I'm just looking at the unit circle for the most part and doing some calculating, so. Okay. Homework quiz.